Welcome. Today I'm going to help you how to solve numerical problems from the model number 1 and 2. So this is I'm solving the problems of new syllabus. It is Introduction to Electrons and Communication. Subject code is BESCK 104C or 204C. So if you see the textbook, the problem number 1, this is a solved problem in the textbook. The statement is a mains transformer having turns ratio of 44:1 is connected to a 220 volts RMS main supply. If the secondary output is applied to a half wave rectifier, determine the peak voltage that will appear across the load. So here the turns ratio is 44:1. So that is N1 is to N2 is 44:1. It's a step down transformer. And input side we have 220 volts. So we have to find out what is the output voltage with the secondary. So for this the formula is the transformer we have N1 by N2 is equal to V1 by V2 or V2, that means secondary voltage is equal to N2 by N1 into V1. So N2 is actually 1. The ratio is given N2 by N1 is 1 by 44 into V2, so into V1. So you have to divide 220 volts by 44. That is formula is V secondary is equal to N2 by N1 into Vp, where N2 is 1 by N2 by N1 is 1 by 44 into primary side voltage is 220. So 220 into 1 by 44 is equal to 220 by 44, which will give you 5 volts. So you can see 1 divided by 44, okay, into 220 is equal to 5 volts, okay. Or you can also directly write V divided 5 volts divided by 220 volts divided by 44, that also give you 5 volts. So this is the secondary voltage appearing across here. At the primary side we have 220 volts. The secondary before diode we are having 5 volts. It is a RMS value, okay. So RMS stands for root mean square value, because in the primary also they are given 220 volts RMS value. So after that the peak voltage of rectification is given by root 2 times 5 volts. So you can see the formulas. I think you can refer formula tab. I'll show you in the formula book. So this is a which you can get it in the exam hall. So this is a handbook of formulas for first year electrical scheme. So here you can see in the front page only, I can see V is equal to IR, V is equal to, in terms of power by current, V is also equal to root of power into R. So resistance is V by I, V square by P, resistance is P by I square, like that. Just a diagram that given. You can see the problem, the main formulas are Ohm's law formula, V is equal to IR. So I is equal to V by R, or R is equal to V by I. Power formula is voltage into current, its unit is watts. Power is also expressed in terms of current as P is equal to I square into R, or in terms of voltage, power is equal to V squared by R. And one more formula, these formulas we are going to use it in electrical, and one more formula you are going to use it. This will fill you in this half wave rectifier. See here, Vrms is Vm by root. So Vm is what? Peak value. So peak value is, just now we calculated 5 volts as the RMS value. So Vm is equal to root 2 times Vrms. Okay, that's all. So this is actually RMS value. 5 volts is RMS value. In order to find the peak value Vm or peak value, it is root 2 into 5. So you can take root 2, okay, 5 into root 2, you're going to get 7.07. So this is the peak voltage appear across if the diode is ideal. But in the problem it is not given. The diode is made up of what? So here you have to assume that only for assumption diodes are ideal, but in all the practicals diode will be made up of silicon. Okay, most of the time diode is made up of silicon. So you can assume diode as silicon, and it consumes the voltage drop across the silicon diode is 0.6. So out of 7.07, 0.6 will be absorbed by the diode. So then remaining voltage only appearing across load. So question is determine the peak voltage that will appear across a load. So we got step down voltage of 5 volts, which is RMS value, multiplied by root 2 gives you peak value. And out of this peak value, 0.6 will be absorbed by the diode, remaining will appear across load. So from this answer 7.07, subtract answer means previous answer minus 0.6 will give you 6.47. 6.47, always answer will be previous answer. Now if I click answer, this will be present answer, this answer. So you can use this answer in the next calculation as by clicking the answer button. So 6.47 you are getting. So this is the first problem. So we got the answer as peak voltage that will appear across the load is, remember you have to subtract voltage across the diode. So if it is given as a germanium diode, you have to subtract 0.3. Otherwise you can specify assume diode as silicon. You can write drop across diode is 0.6. 0.6 will be absorbed by the diode from this peak voltage. So remaining voltage is 7.07 minus 0.6 is 6.47 is appearing across this. Let us go to the next problem. Problem number 2. So it is a problem on smoothing filter circuit. So the RC smoothing filter in a 50 Hz main operated half wave rectifier circuit consists of R1 is 100 ohms, C1, C2 is 1000 microfarad. This C2 is 1000 microfarad, and this is RC filter. R1 and C2 acts as filter, RC filter. If the 1 volt is 1 volt of ripple appear across the input of the circuit. Input means after the diode is a half-wave rectifier diode. Output of rectifier is pulsating DC. It contains ripple content. So you have to remove it. So the value of the ripple content after the diode is 1 volt, and it's connected to the smoothing circuit composed of RC, R1 and C2. And you have to find out after the smoothing filter what is the value of ripple content. And ripple content value before filtering it is 1 volt. Now it is reduced to how much you have to find out. So filter is actually it removes the ripple. So definitely 1 volt ripple will be reduced to millivolts. Let us say now. So the theory part you can refer textbook or class notes. So the formula for you have to find out reactance of capacitor as Xc. X is equal to 1 by omega c. Reactance of capacitance is omega c. Omega is 2 pi f. So that is also omega value. I think in the formula book you can see omega is equal to 2 pi f. So 1 over omega c means 2 pi f into c. So take calculator, 2 into pi into f is 50 hertz into 1000 micro, 10 to the power minus 6. So this is I am writing just 2 into pi into f into c. So actually this is denominator. So you have to take reciprocal of this. So calculate the answer is equal to. So this is actually the answer. I want to get, this is the answer. Denominator part is this. So 1 divided by this. You can do 1 divided by answer, or you can do x inverse. So this denominator, if you take inverse, okay, let me take show you first answer only. Now 1 divided by the previous this answer, multiplication of this. So it is getting 3.18. Okay, 3.18 is the answer. That is actually you can express now reactance of the capacitance as ohms only. So after that, we have to voltage, this acts as a voltage divider, RC network acts as a voltage divider. Okay, so we can find out what is the portion of output voltage across capacitor is voltage divided by magnitude. Voltage divided by magnitude. Magnitude is root of R square plus X square into voltage across this AC, because RL is parallel to C2. So we have to find out reactance of C2 is 3.18. So now this is the 3.18. You can take that as answer, or you can just remember 3.18. So 1 is this volt. 1 is ripple voltage, 1 volts. So 1 divided by, okay, first 1 divided by root of, otherwise 1 into, first you can do 1 into 3.18. It is 3.18 only, divided by, let's see, it will take the previous as the answer, divided by root of, open the bracket, R square. R is 100 given. Okay, R value is 100. You can see here R1 100 ohms. So it's 100 square plus XC. XC is 3.18. 3.18 square. Close the bracket. So we are going to get 0.0317. So this you have to express in terms of millivolts. So you can write 0.031 volts. Otherwise, if you want to express in millivolts, there is a ENG button. So just click on ENG button. You can take the, you will get the 31.7 millivolts. Okay, or if you round off, you will get the, it is approx 78 means you can approximate to 38 volts. So you can write 31.7, or you can write approximately equal to 32 millivolts. See, 1 volts means 1000 millivolts. 1 volts means 1000 millivolts is reduced to just 32 millivolts. So we are removing 970, approximately 970 RMS value, that ripple content we are removing. So you can see. Similarly, if you press the ENG button, you will get macro, and if you want to go reverse, the 31.72 you can write. Otherwise, you can write just 0.03 volts also you can write. Okay, this is second problem. So now next problem is this is the problem. It's unsolved problem in the textbook. If you want, you can solve this. So in half wave rectifier is fitted with RC smoothing filter. Now R value is instead of 100 they are given 200. C value is 50 microhertz, and ripple content before filtering it is 2 volts, and given frequency is 400 hertz. So you have to find out what is the amount of ripple at the output. So for this I given as assignment. So those are solved, you can solve that. So formula is, first you have to find the reactance of capacitance. Reactance of capacitance is 1 by omega c. So 2 into F. F is how much for this problem? 400. 400 into 2 pi f. Okay, 2 into pi. 2 pi f, no. 2 into pi into f, 400. 2 pi f c. C is how much? 50 micro. 50 10 power x minus 6. So this is 2 pi f omega c. So this is the answer is this much, and 1 over omega c means 1 divided by answer, previous value. So 7.95, 7.95 ohms. Xc is 7.95 ohms. Remember, 7.95. After that, if you go to previous, so this one we got 7.95. After that, V ripple is, in the previous problem 1 volt ripple was there. In the new problem, 2 here you have to write. X is 7.95, root of, instead of R is equal to 100, you have to write 200. Okay, 2 volts, 200. So this is 7.95. 7.95. Okay. So 2 into 7.95. This 2. 2 into 7.95 is equal to answer divided by root of 200 square. So to write here bracket, if 2 plus terms in between, if it comes, so to take all. So that's why you have to write bracket. If you don't write bracket, you will get wrong answer. 200 square plus 7.95 square. Close the bracket. So you're going to get 0.079 volts. Otherwise, you can express, you can write instead of 0.032. Now, the new problem, assignment problem, answer is 0.079. And you can express in millivolts also. Click ENG button. You can also write 79.4 milli, 10 to the power of minus 3 means millivolts. So the answer for this is 79.43 millivolts. This answer, you can verify your answer now. So problem number 3, which is Zener diode. A 5 volt Zener diode has a maximum power rating dissipation of 500 milliwatts. If the diode is to be used in a simple regulator circuit to supply a regulated 5 volts to a load having resistance of 400 ohms, determine suitable values of series resistor in conjunction with supply of 9 volts. So this is the purpose of regulator is, if the supply voltage varies, the Zener diode should provide a constant regulated voltage. That value depends on Zener breakdown voltage. So since we want a regulated voltage of 5 volts, you have to select a Zener diode whose breakdown voltage is 5 volts, and input should be greater than this breakdown voltage. So input is given as 9 volts. Actually, we want V naught of 5 volts. Here 5 volts, so input is greater than 5. So it is 9 volts. So you have to find out what is the minimum value of RS and maximum value of RS. So you can refer notes. Formula for RS max is V in divided by Z minus 1 into RL. So input voltage is 9 volts, VZ is 5 volts, minus 1, but you have to multiply with RL. Input voltage divided by breakdown voltage minus 1 into RL. So calculator usage is very, very important. First, start with, don't multiply 400. Let us do that 400 later. First, open the bracket. Okay. 9 divided by 5. V minus VZ I am doing. Okay. This minus, answer minus 9 by 5 minus 1. We'll get new answer as 4 by 5. This you multiplied by 400. So it is 320 ohms. So another RS minimum value is given by V in into VZ minus VZ square by PZ max. So PZ max is given as 500 milli. 500 milli is 500 milli. 500 minus 3. This is 500 minus 3 is equal to is nothing but 0.5. Okay. See, if I type 0.5 and click ENG button, you'll get 500 milli. So this is the 500 milli. You can also write 0.5 watts. Okay, you can click shift ENG. It will give 0.5 into 10 power of 0 is 0.5 only. Okay, now RS minimum is equal to V in into VZ minus VZ square. So first you have to start with V in is 9. 9 into 5 is 45 minus 5 square is 20 divided by 0.5. So it is 40 ohms. So since we are finding resistance value, unit you have to write, unit of resistance is ohms. So the value of resistance should be greater than 40 and less than 320. You can write RS any value between these. Okay, here they are given. Suitable value of RS is 150, which is lies between greater than 40 and less than 320. Or you can also write 100 ohms, or you can write 200 ohms. You can also write 300 ohms, or just you can write greater than 40, less than 320. Any resistance value you can specify. That should be standard value. So this is a assignment problem given. Here remember a 5 volts Zener diode. If a 5 volt Zener diode means breakdown voltage of Zener diode is 9 volts. It can be used in a simple shunt means parallel regulator to a supply of load having a nominal resistance of, this is load, to supply a load resistance of 300. Load resistance is now 300 ohms. Determine maximum value of series resistor. Only maximum rest value we have to find out. Determine maximum value of series resistor in conjunction with a supply of 15 volts. So this is the value of RS max. Okay, here determine the suitable value of series resistor. So we have to find out minimum value and maximum value. I think in this problem they asked to just determine maximum value. So formula for maximum value is V in by Vz minus 1 into RL. So V in here, Vz is 9 volts because they are given 9 volts in. So breakdown is 9, RL is 300, supply voltage is 15. So remember Vz is 9, supply voltage is 15, RL is 300. So the value of RS max is V by Vz minus 1 into RL. So now V in is what? New problem. Supply voltage is 15. V in is 15. Vz is 9. V in is 15. Vz is 9 minus 1 into RL. So answer is 200 ohms. So answer for this problem is 200 ohm. So refer here, same problem. V in you substitute as, okay, V in is 15 volts. Okay, then Vz Zener diode that given as 9 minus 1 what to do, then multiplied with RL values 300 they are given in this assignment problem. So it is 200 ohms. So only you have to find out RS max because determine maximum value of series resistor. If you want, you can also calculate RS min using this formula. Substitute here 15, 9 minus 9 square. PZ max is not given. That's why I think they are not asked minimum value. Okay, for this only maximum resistance will be total. So next problem is the following data were obtained during the test carried out on a DC power supply. Load voltage, no load means open circuit and current is 0. Current value is 0, so 12 volts. Output voltage with a load current of this is 2 amps load current. Here no load. Okay, current is 0. Here current is 2 amps. 12 amps, 1.5 volts. Regulation test is output voltage 12 volts. Output voltage main input is 200. It is 11.9. Determine equivalent output resistance and regulation of the power supply. This is also given in the notes. You can find out the output resistance is given by changes in the output voltage divided by changes in output current. So changes in the output voltage you can see 12 and 11.5. Current is 0 here. No load means open circuit. So current is 0 and another current is 2 amps. So change in output current is 2 minus 0. Changes in the output voltage is 12 minus 11.5. So 12 minus 0.5 is 0.5 divided by 2. So half divided by 2 is 0.25. Okay. And regulation is changes in output voltage divided by changes in the input voltage. Input changes you can see. Input main supply is changed from 220 volts. Another value is 200. So delta V in is 20 volts. Okay. 220 minus 200 is 20. And changes in the output voltage. With the regulation test, we have different output voltage value. In the load test, we have different output voltage. So since we are calculating regulation, so consider output voltage 12 and it is changed to 11.3, and changes in the supply voltage is 220 and 200. So 12 minus 0.1 is 0.1, 220 minus 20 is 20. So 0.1 divided by 20 is into 100 is the regulation percentage. Always regulations are expressed in percentage. So 0.5 by 20 into 100%. So you can see uh, 0.1 divided by 20, we get some answer. Sorry, if I click is equal to, we'll get some answer into 100% is equal to 5. It is 0.5 percentage. So 0.1 into 20 into 100 percentage symbol you have to write. So next we have problems from module number 2, which is amplifier. In the first problem, that's the first module only, amplifier topic. So an amplifier produces an output voltage of 2 volts for an input of 50 milli. If the input and output currents of this are 4 milliamps and 200 milliamps. So meaning of this one is output is 2 volts, input is 50 milli. 50 millivolts if I give, amplifier will give you 2 volts after amplification. And input current is 4 milliamps, and 4 amps is multiplied and amplified into 200 milliamps. You have to find out voltage gain, current gain, and power gain, input resistance and output resistance. So here formula for voltage gain is normally output value by input value. So if it is a voltage gain, A stands for gain, V subscript gain stands for voltage. So it is voltage gain. It is output value by input. Since you are calculating voltage gain, output voltage by input voltage. So output is 2 volts, input is 50 milli. So you have to take calculator, 2 divided by 50 milli. 50, you should be very careful, don't miss milli and all. So 2 divided by 50, 10 power minus 3 is milli, you will get 40. So don't write to volts and all, it is how much time it is amplified, just the number you have to write. Voltage gain means input is amplified by how much time, it is 40 times it is amplified. Don't write volts and all. Okay. Similarly, current gain is AI, it is I out by I in, output quantity by input quantity, and it is current. A means gain, I means current. Current gain is output current by input current. In the problem, it is given that 4 amps is amplified to 200. So here, both the sides we have numerator and denominator, milli is there, it will get cancelled. It is just equal to 200 by 4. 200 divided by 4 is 50. Again, current is amplified by 50. Don't write amps and all. So power gain is given by power formula is V into I. So output power is V out into I out. Input power is V in into I in. So V out by V in is nothing but voltage gain. V out by I in is current gain. So we already have AB is how much? 40. AB have 40. AI is 40 into 50 is 2 zeros. 0, 0. 4 5s are 20. So 2000. Okay. So this is the answer. So again, power amplification is also no unit. So power is amplified by 2000 times. Similarly, I can calculate input resistance and output resistance. For example, I will show you here. Input resistance is in the formula book, you can see resistance is V by I. Input side means input voltage by input current. Input voltage is 50 milli. So take 50 milli also you have to write. If you miss milli, you will get wrong answer. 50 milli divided by input voltage by input current, 4 milli. 50 milli divided by 4 milli. 50 milli is the voltage. Okay. And input current is 4 milli. So milli will get cancelled. It is equal to 40 by 50 by 4, it is 12.5 ohms. So here you have to write ohms. Input resistance is 12.5 ohms. Similarly, output resistance is output current by output voltage by output current. Output voltage is 2 divided by output current is 200 milliamps. So this will give you 10 ohms. So this is how to solve the problem on amplifiers. So next problem is an amplifier with negative feedback applied to an open loop voltage gain of 50. So this is a gain without feedback. An amplifier with negative feedback as an open loop. Open loop means no feedback. So A value is 50 and beta factor is 1 by 10. 1/10 of its 1/10 means 1 by 10, which is equal to 0.1. Determine overall gain. So in the formula derivation with negative feedback, gain with feedback is given by AF. Okay, AF is A divided by 1 plus A beta, where G or AF is gain with feedback. Gain with feedback is given by gain without feedback plus 1 plus gain without feedback into 50. So A is given without feedback means open loop gain. Open loop gain is 50, beta is 0.1. So A divided by 1 plus A beta. So A calculated is very, very important calculation. So gain is 50. So now you have to put bracket. If you have plus and all in the denominator, you have to divide by whole. So 1 plus A beta. A is 50 once again. Beta is 0.1. 0.1. Close bracket. So this will give you press SD. It will 8.33. 8.33. Okay, 8.333. That's why the same it is repeating. That's why 3 bar came. Okay, next part B. If the amplifier open loop gain is increased by 20. Okay, gain is increased by 20. Original gain is 50. 50 if you increase by 20, AV is added with 0.2. 20 means 20% means 20 divided by 100 is 0.2. So AV plus increased value 20%. So 0.2 of E. AV plus 0.2 AV is 1.2. Okay, 20%. It is 0.2 plus original gain. So it is total 1.2 AV. Okay, and AV value is 1.2 into AV is original AV is 50. So it is increased to 60. Original gain is 50. Now new gain is 60. So you have to find out if the gain is increased by 20%. That means AV becomes 60. Then what is the value of gain? Beta is same only. So now take instead of 50, take AV as 60 divided by open bracket. If in the denominator plus and all is there, you have to write whole bracket here. 1 plus 60 into 0.1. So it is 8.57. So original when the gain is 50, 8.33. Now it is the gain is increased by 20%. Now it is from 8.3 it is reduced increased to 8.57. So how much it is increased? You have to calculate 8.57 new gain minus original gain 8.33 is equal to, you have to write, don't write divide now only, otherwise in the numerator and the denominator if plus or minus term is there, you have to write bracket, otherwise you calculate is equal to divided by 8.33 into 100%. It is 2.88 percentage you have to write. Okay. So next is problems on oscillators. Determine the frequency of oscillation of a three-stage ladder network with C is equal to 100 nanofarad. R is equal to 10 kilo ohm. So for RC network, RC phase shift oscillator formula is given by 1 over 2 pi RC into root 6. 1 over 2 pi RC into root 6. Here root is for only 6. Okay. C value is given as 10 nano. R is given as 10 kilo ohm. So take calculator. So I'm calculating. First, I will calculate the denominator. After that, I will take 1 divided by answer. So 2 into pi into, you can write 2 pi directly or you can write into also, no problem. 2 into pi into RC. Okay, R value is R value is 10k. 2 pi RC I will do first. Okay, it is 10 power 3. Okay, 10 into, once again I will repeat, 2 into pi into R is 10k, 10k plus 3 into 10 nano, 10 into 10 power x minus 9. Okay, I'll repeat once again. 2 into pi into 10k, 10 into 10 power 3, 10 into 10 power 9. So it is denominator part. So if I click is equal to, it will show you denominator answer. This denominator answer. This I have to do 1 divided by this answer. So take 1 divided by answer button is 1591. No, I forgot to do root 6. That's why I'm getting wrong answer. So again, this answer divided by root 6. This 649 actually it is coming. Or if you want to do continuously, 2 pi, sorry, 2 pi R value 10 power 3 into 10 nano into root 6 is equal to, this is the denominator, and you can also click x inverse or 1 divided by answer. I will do x inverse now. Answer, that is answer to the power minus 1 means 1 divided by answer will give you 649 only. 647 is wrong, 649 is correct answer. So unit of frequency is hertz. So next problem is on Wien's bridge oscillator. It has 4 arms. So figure shows the Wien bridge oscillator using op amp. This is op amp. If C1 and C2 is 100 nano, determine the frequency produced when the R1 and R2 is equal to 1 kilo ohm, and when R1 and R2 is 6 kilo ohm. So for Wien bridge oscillator, the formula is 1 over 2 pi root of C1 C2 R1 R2. Under the root, C1 into C2 R1 into R2. Since C1 and C2 are same, root of C square is C only, and R1 R2 is same, root of R square is R only. So root of C square into R square is CR only. So that's root part will go if both are same. C1 and C2 is same, R1 and R2 is equal to same. So formula is reduced to 1 over 2 pi RC. Otherwise, 1 over 2 pi root of R1 C1 R2 C2. Okay, now take the calculator and find out. So C is given, R is given. C is, first I will do 2 into pi into C is 100 nano. C1 and C2. 100 nano into R value. First case is R value is 1 kilo ohm. 1 in power 3 is equal to, this is the answer in the denominator. So you have to take reciprocal of the answer or 1 divided by answer. So answer inverse is 1591 hertz. Here it is expressed as kilohertz. So you can click ENG button If you want to do milli, you have to click ENG button, or you can click Shift ENG button. See, if I click ENG button, it will show 10 power 0, 10 power minus 3 and all. If you go reverse, Shift ENG button, so once it becomes 10 power 3, stop 1.59 kilohertz. So second case is what? R value instead of 1 kilo ohm, for R value is 6 kilo ohm. What is the answer? So you can go here 2 into 5 into C value is 100 nano into 6 kilo. 2 pi 100 nano 6 kilo is equal to, this is the answer, and reciprocal answer x to the power of minus 1 or 1 divided by the denominator answer. It is 265 hertz. If you want to express in kilohertz, 0.26 kilo. Otherwise, normal, I can write 265 into 10 power 0 means 1. 265.2 hertz only. So thank you.